All right, so let's take a look at some of these applications. And some of the problems we're going to deal with have percentages which lead to growth and decay rates. We're using our regular formula that we've used the whole time, but you're going to see a new thing introduced, which is R for growth or decay rate. All that does is to create your new B in the formula, either your growth or decay factor. If it's a growth factor, you add 1 to your rate, you turn your percentage into a decimal. Decay, same deal, 1 minus the rate becomes a decimal. This should be less than 1, as we've learned that decay graphs are going to be the ones that go down, and growth ones should go up. We learned about numbers between 0 and 1 indicating decay, numbers greater than 1 indicating growth. So when you do your rates, it should work out such a way. Let's take a look at a couple problems. In the first one, there are currently 46 bunnies, and they quadruple. That's not a rate problem specifically, but it does lead to a different type of formula that you're going to see during this. This is after 8 years according to the problem, so we're plugging 8 up there. This is just a standard problem that you've been dealing with the whole time. And there's a lot of bunnies. Okay, so that's pretty easy. Now I'm going to throw a couple wrinkles at you. In this problem, it's asking what happens if bunnies quadruple every 3 years. To make that adjustment in our formula, the change is on the time. In our problem before, we talked about time being 8 years. And we put that as our exponent. As you remember, way back when, x is time, when we're thinking about independent, dependent variables. So if we're trying to adjust our time to be every 3 years, we'll just put our exponent over 3. And if you're going to plug in your calculator, make sure you use parentheses after you put that to the x over 3 power. And then from there, to do these problems, you would put in the 9 over 3 power. You're talking about after 9 years, and 16 over 3, if you're talking after 16 years. Some of them will simplify, like this one will simplify to 3. This one's going to be an ugly decimal, so just leave it as the fraction up as the exponent. I don't need to do all the work, you can do that yourself. In number 5, we're going to talk about going and solving a problem in a slightly different way than what we have in the past. In this problem, we have the current amount of bunnies. We know that they still quadruple every year, and we're trying to figure out how many there were 5 years ago. So our time is still 5. We still have quadruples. We currently have, y is our current value. So we're going to plug in the 28,672 for y, and we're going to solve for a. As you can see here, it looks like some pretty simple algebra. If we just divide by 4 to the 5th, or you can simplify 4 to the 5th and then divide, it doesn't really matter. Then you'll be able to solve for your A, or your initial amount, which is how many bunnies there were 5 years ago, which is presumably when this new problem started. And it would be 28 bunnies when solved out. Keep in mind, if you ever get a portion of a bunny, make sure you round down. You can have portions of bunnies. Onward. So, in the next problem, we're talking about a car that sells for $18,000 and depreciates by 25% each year. This is one where you'd have to use the rate formula. It's either going to be 1 plus R or 1 minus R. In this problem, we're talking about depreciates, which means it's going to go down, so it's going to be a decay. Our rate is going to be 25% into a decimal. To turn percents into decimals, take the decimal point that's here and move it 2 to the left, so it would be 0.25. So of course our starting cost is 18,000, and then our decay factor is going to be 1 minus our rate, which is 0.25, which is 0.75. So what that basically means is after every year you have 75% of the value remaining. And if it were an added number, so it'd be 1.25, it means it grows by 25. You have your whole initial number and then 25% on top of that. So the new function would be and then for the last one you can plug in 4 for years if you'd like. But that's it. It's just basically turning your percentage that you're given in the problem to a decimal, determining whether the problem is a decay or a growth, and using this small formula to create your B. One last type of problem you would encounter would be percent increase decrease when you're not given a percentage. So you need to use values given to you. In this problem, you're going to have a new value and an initial value, and you're just going to use this formula to solve for R. In the problem given, the school now has 812 students. The school last year had 756 students. So you clearly see that it's growing. You should expect your R to be a positive number that you would add to 1. If it were negative, you'd subtract it from 1. But we're going to use this formula. R equals our final value, which is the newest value, minus our initial value, which is our starting value of 756 in this problem from last year, and again over the initial value. Simplify the top before dividing, or if you want to do it all at once, put the top in parentheses so your calculator doesn't do funny things. And I get 0.074, which if we're talking about the rate, that is the rate. The factor would be 1 plus that number. Because we had the whole population of 756 and 7.4% more. And then you would just use that as your B in the formula.